Hey guys, welcome back. Today we're going to look at CASEL Unit 5, Activity 4. And what you're going to notice is that it's actually pretty similar to Activity 2 and 3, but kind of combining the two of those. What we're going to do first is we're going to assemble the circuit with a 3-cell battery and a round and a long bulb in series, which is exactly what CASEL Unit 5 Activity 2 was. And so here I've got this circuit built here, and I've already got a couple of compasses there. We're going to use the compass to examine the flow rates in wires A and B. And what you're going to see from up here is that even though only the long bulb lights, here's the long bulb here and here's the round bulb over here, even though only the long bulb lights, we do see a charge flow in both of those wires. So you see in the first wire that leads from the battery into the round bulb, we see it deflects maybe 2 to 5 degrees. It's pretty small, but it does deflect, so there is charge flow there. Whereas over here on the wire in between the round bulb and the long bulb, we do still see that small amount of movement. Okay, now both of them are pretty small, and it is an imperfect science due to the fact that my own phone, as well as a lot of the other electronic devices that are in my house, the batteries, the compasses themselves, they're all magnetized, so they do have that small effect on each other. So we because it is so small, what we're seeing in the wire right here, it's hard to say that they are the same. But what we do know already is that in the same loop, the charge flow must be the same. So unfortunately, this is an imperfect science that we're looking at, and there's a lot of interference here, but take my word for it, I guess, that the charge flow is the same through both of those wires, because that is what we have seen before. But what you do also see is that the brightness of the long bulb is a lot more than the brightness of the round bulb. In fact, the round bulb is not lit. And again, what we talked about a little bit on last week was this principle of series voltage division, which basically says that the thing in series that has the larger resistance is going to have more of that pressure difference across it. So the battery has a specific pressure difference. This one having 3 cells is 4.5 volts. The long bulb is going to take most of that, and the round bulb is going to take less of that. And that's because the resistances are different from each other. And that's something, again, that we talked about a little bit last week. So if we were to color code that, then we would see that that red to blue across the battery, well, we're not going to have yellow in the middle. Actually, it's going to be pretty much red. You see here, I kind of drew it as orange with some red in it because it's not exactly orange and it's not exactly red. It is kind of a qualitative science that we're saying here. Basically, the pressure difference is very small, and the pressure difference across the long bulb is very big. Okay, that's what really matters. And what we're going to do now with activity 4 is we're going to add another bulb in parallel with that long bulb. And this is kind of like the activity that we did more recently. On Friday, we did activity 3, which was adding another round bulb in parallel with a round bulb. And we saw that adding that round bulb to right here basically decreases the resistance. And the same kind of logic is going to follow here, where we're going to say, all right, well, when we add a bulb in parallel, we're going to decrease the resistance. And it's going to have to be less than either of the bulbs that are there. So we're going to wind up decreasing this resistance so that it's less than either long bulb by itself. And then when we add a round bulb, we're going to be decreasing it so that it's less than either the round or the long bulb itself. And similarly here, we would be doing the same thing, I guess, but this wire already has a very, very low resistance. What I want you to do now is to go ahead and make your predictions about this. Okay, we'll kind of walk through this table so that I make sure you can understand it. First, we have this round bulb, and we want to say, all right, before in circuit 1, before we connect wire C in circuit 1, how bright is the round bulb? Well, let's go ahead and look at it. When we have this circuit here, circuit 1, before we connect that loose wire that you see right up here, before we connect that wire, you see the round bulb is not lit and the long bulb is bright. So we have the round bulb before is not lit and the long bulb is bright. What do you think is going to happen after? Is the round bulb going to be lit? Is the long bulb going to get dimmer? Up to you. Okay, these number 2 and 3, you see before we connect that wire, they're all the same circuit. Okay, so before we connect the wire, the round bulb is always going to not be lit and the long bulb is always going to be bright. Okay, and you're basically supposed to be predicting whether this long bulb is going to get dimmer. Is it going to go to dim? Is it going to be not lit? Up to you to decide on that, I guess. Okay, and the flow rate, is it going to increase, decrease, or remain the same in all of the wires? Now, in wire C, we start out with 0 flow rate because it's not connected. So obviously, if we're going to have flow through wire C, then the flow rate increased. Okay, so the flow rate obviously has to increase in wire C because it started out as 0. Okay, but before we connected it, we saw that the flow rate through A and B, they were the same, and they were both pretty small. Do you think that the flow rate in either is going to increase, decrease, or remain the same? Again, these are wires A and B. A is the one that goes out of the battery and into the round bulb, and B is the one that goes out of this section right here and into the long bulb. I want to make it clear that wire B is not, it's not this part. It's not that part. It is specifically this part, the wire that leads into the long bulb. Okay, so on here, it's going to be just this yellow wire. It is not connected to that red wire in any way. Okay, so I'll give you a moment to make those predictions. You can go ahead and pause the video so that you have time to make your predictions. Do please make educated and reasonable predictions, and then we're going to go ahead and go ahead now. Okay. So here we have the circuit before we connect that loose wire. And I'm going to do 2 things here. First, I'll show you the effect on the brightness, and then I will show you the compass. Okay. This is hard with my left hand. Okay. We see that that first round bulb still did not really light. Okay, so that first round bulb still did not light. We also see that the long bulb stays pretty bright. It looks like it does dim very, very slightly, but not a lot. It stays pretty much the same brightness, and then both of those long bulbs are the same brightness. Okay, now if I come over here and we look at that compass, you see it does move quite a bit. That's like maybe 10 degrees, which is a lot. Interestingly, this one we still see, oh, well, I suppose that, okay, and then when I, so when I connect it, we see that This wire, it doesn't change. Not really, right? Okay, so wire B doesn't change. Wire C obviously increases because it started at 0. And wire A does increase. The flow rate does increase on wire A as well. Okay, cool. I'm gonna go ahead and swap out this bulb now with a round bulb. So while I'm unscrewing that, we saw that with the long bulb added in parallel in circuit 1, we did see an increase in the charge flow on A, but not on B. And we did not see the brightness of bulb A change at all. So it changed, but it didn't change by enough to actually light that bulb. Okay. Now I'm replacing the long bulb from circuit 1 with the round bulb in circuit 2. Here's what we see this time. Oh, interesting. Okay, so now both of these round bulbs are lit. And they're actually lit about the same brightness, I think. Would you say so? This one might actually be a little bit dimmer. Okay, so the bulb that's in parallel might actually be a bit dimmer, but it's hard to tell. And we do see that long bulb there dim as well. Okay, which would suggest that that long bulb probably has less flow now. Okay, let's look at this compass here. We see that adding that does again increase the flow rate through wire A. I don't know if you can really see that moving. I haven't seen that compass move at all. I'm not really sure how I feel about that. But since that one is less bright, that would suggest that it does have a lower flow rate than before. I'm sorry that you can't really see that on the compass, but since it is less bright, it does suggest that the flow rate is less there. Okay, and we see quite a bit of movement on this compass as well, again. Okay, so here we saw that long bulb did dim when we added the round bulb. And that's because that round bulb has less resistance than the long bulb. And so more of that charge is going to choose to go through the round bulb than the long bulb, because that round bulb has less resistance than the long bulb. And so adding them in parallel with each other makes the round bulb take most of that charge flow. Okay, let's also go ahead and see what happens when I just have a wire here and I've just connected them both on the clip because I only have one hand. So this part is not in the circuit and that charge is just going to move straight through here as if it's just one wire. Okay, now what we'll see here is that this is a shorting wire, which means that since it's in parallel with that long bulb and it has almost no resistance, that long bulb is going to go out entirely, and we're going to have a very, very bright round bulb at the beginning. Now right here you see that, I think I actually did see a little twitch there. Just a little one. Okay, and it is a decrease in flow. Again, I mean, you'll just kind of have to bear with the technical difficulties here. Since that bulb does go out, obviously there is less charge flow now. Okay, and here we see a very large increase in that charge flow again in wire A. Okay, so on circuit 3, in wire A, we have more flow rate, quite a bit more. In wire B, it must be less because this bulb goes out, just like how it must have been less last time because it was dimmer. And here, obviously, it's increasing because there is no flow in it before, and now there is, okay, but We'll just see that. Wow, look at that. That is crazy. Okay. All right, so go ahead and let's make those observations here. So go ahead and fill out the observation side if you haven't already. You should have been doing that while I was doing the activity. If you didn't quite get it down, maybe go back through and watch some of this video again. I am going to go ahead and upload this section of it, and then I'm going to make a PowerPoint with some notes, and I will upload a second video of me narrating those notes and drawing some pictures for you on my computer. Okay. Good luck with everything. Talk to you guys later. Bye.